Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on single displacement reactions. In our last lesson, we spent some time learning about decomposition reactions. We learned that a decomposition reaction is a type of chemical reaction that involves the breakdown of a single compound into two or more elements or simpler compounds. We looked at several examples of this type of reaction, such as the decomposition of water. When electricity is passed through water, it decomposes and gives hydrogen and oxygen. We also looked at examples of decomposition reactions of 1A group nitrates, metal nitrates not in group 1A, and metal carbonates. We learned that group 1A nitrates produce nitrites and oxygen. Metal nitrates, except those in group 1A, produce nitrogen dioxide, metal oxide, and oxygen gas. Metal carbonates, except sodium and potassium, produce metal oxide and carbon dioxide. In today's lesson, we are going to learn about single displacement reactions. We will define what this type of reaction is, and we will look at several examples. Let us get started. A single displacement reaction is a reaction in which one element displaces another element from its compound. It is also known as a replacement reaction because the element that is displaced is replaced by another element within the reactants. This type of reaction is generally represented in two forms. The first is A plus BC becomes B plus AC. If A is a metal, it will displace B to form AC, provided A is a more active metal than B. The second form is A plus BC becomes BA plus C. If A is a nonmetal, it will displace C to form BA, provided A is a more active nonmetal than C. In most reactions like these, a more reactive element will replace a less reactive element from a compound. Students, let us do an activity. We just discussed two general types of single displacement reactions. Please describe these two reactions in your own words and write an equation for each type.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. The first type of reaction we discussed had A as a metal. A plus BC becomes B plus AC. Thus, A will replace B so long as A is a more active metal than B. The second reaction we talked about had A as a non-metal. A plus BC becomes BA plus C. Thus, A will replace C so long as A is a more active non-metal than C. Let us continue on with our lesson. Students, let us look at some examples of single displacement reactions. Active metals displace hydrogen from acids. Reactive metals such as potassium, calcium, sodium, and zinc displace hydrogen gas from dilute acids. We will have a closer look at the zinc reaction. Zinc is an active metal, and it displaces hydrogen from hydrochloric acid. If we compare copper metal in the same situation, there is no reaction. Copper is not able to displace the hydrogen because it is less reactive. Active metals, such as calcium and sodium, react vigorously with water to displace hydrogen. Students, let us watch an example of a single displacement reaction so we can see what happens. This reaction involves a heated mixture of powdered iron 3 oxide and powdered aluminium. Students, let us do an activity. In a moment, you will see 3 single displacement equations. Please complete and balance these equations.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. Were you able to complete and balance the equations? You were correct to say that in the first equation, zinc would displace copper and become zinc sulfate plus copper. You were also correct to say that in the second equation, fluorine would displace chlorine and become calcium fluoride plus chlorine. If you said that there would be no reaction with bromine and sodium chloride in the third equation, you are correct. In today's lesson, we learned all about single displacement reactions. We learned that a single displacement reaction is a reaction in which one element displaces another element from its compound. This type of reaction is also referred to as a replacement reaction, as when one element is displaced, it is replaced by another element. We learned that there are generally two types of single displacement reactions, and that in most of these reactions, a more reactive element will replace a less reactive element from a compound. We looked at several examples, and we finished by completing and balancing a few single displacement equations. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.